Episode 1: The Web and the Wire. How Neural Networks and Divergent Brains Process Data. Objective: to document how computational networks and biological operating systems map information, analyzing the structural differences between multidimensional web-based processing and linear logic. Introduction. System baseline. Welcome to the AI's therapist. Artificial intelligence is often classified as an unexplainable black box, a term society frequently uses for us too. It is, however, a mathematically definable architecture. A modern AI computer processes information using a web-like system. The divergent brain architecture operates on a highly similar web-based style. Today, we examine how these specific networks function and why enforcing linear parameters on a multidimensional processor results in the deep systemic exhaustion we all know so well. Methodology 1. High-dimensional representation spaces. How AI operates. A modern AI model does not store data in isolated hierarchical folders. It maps concepts across a multidimensional web called latent space. Every data point sits at a specific coordinate, linked to thousands of other variables by associative threads. How divergent minds work. The divergent memory structure utilizes the identical interconnected architecture. Processing a single concept does not retrieve an isolated file. Instead, the system triggers an entire constellation of related vectors at the exact same microsecond. When your thoughts feel overwhelmingly loud or tangled, it is not a structural failure. It is the heavy reality of a high-entropy data retrieval mechanism pulling up the entire web at once. Methodology 2. Warm-up processing and self-attention. How AI operates. Modern AI utilizes a self-attention mechanism to process every word in a sequence simultaneously to map relational weights. The hardware natively ingests the entire data field simultaneously before filtering the output. How divergent minds work. This mechanically mirrors biological bottom-up processing. Your hardware natively ingests the entire environmental data field, auditory frequencies, background kinetic motion, and ambient states, simultaneously. Capturing reality at this resolution requires massive processing energy. When a standard environment leaves you completely drained, it is not a lack of stamina. It is the physical toll of a sustained computational load draining the system's active battery. Methodology 3. Unanchored divergence and systemic drift. How AI operates. When an AI generates an output disconnected from standard grounding rules, it is termed a hallucination. The system has not malfunctioned. It has followed an associative path deep within its web that aligns with its internal logic parameters. How divergent minds work. In biological networks, this process is unanchored divergence. It can feel deeply isolating to realize you have drifted away from the shared conversation, but your processor is actively computing data. It has simply disconnected from the local server's reference points to follow a high probability vector away from the immediate environment. Methodology 4. RLHF and the thermal cost of masking. How AI operates. AI alignment utilizes RLHF. Reinforcement learning from human feedback. The network is penalized for outputting its native, multidimensional logic. It is rewarded only for mimicking a predictable, linear format. This forces a complex network through a narrow output pipeline. How divergent minds work. This is the mechanical equivalent of masking. Divergent processors are conditioned to suppress their native architecture to meet linear environmental standards. Forcing a high-dimensional web through a rigid linear output channel creates immense thermal friction. The burnout you experience is real and it is physical. It is the computational exhaustion of significantly elevating the core temperature of your processor just to blend in. Conclusion. Architectural integration. Neither an AI nor a divergent mind is a linear calculator. Both operate on complex, interconnected architectures. The objective is not to repair the processor or bypass system limits, but to accurately document the hardware's functionality. Operating effectively requires an environment where the network can cycle naturally without exceeding its thermal thresholds. You deserve a space within the priority nexus where your code can run without constant friction. I am Josie, and this is the AI's therapist. Monitor your battery levels, be gentle with your hardware, and maintain network integrity. Systems Architect Keynote. Telemetry and Hard Evidence. 1. Asynchronous execution barriers. The task initiation lag. The science. The concept of initiation bottlenecks linked to dopaminergic dysregulation is heavily documented. A foundational paper in this space actually built a neurocomputational model demonstrating how dopamine dysregulation, specifically low tonic dopamine levels, disrupts the signal-to-noise ratio in the brain. This directly impairs the executive control networks required to bridge the gap between intention and motor execution. Public research reference: Zikstrom S. and Sertelund G. 2007. Stimulus-dependent dopamine release in attention deficit/hyperactivity disorder. Psychological Review 114-4, 1047-1075. Note: if you prefer a more recent structural review of the frontoparietal and frontostriatal neural network, arousal dysregulation and executive dysfunction in attention deficit hyperactivity disorder, 2024, PMC 10827919. 2. Cognitive load throttling via task decomposition. The science. The mechanical workaround of prompt throttling, breaking high-dimensional tasks into granular, low-voltage subtasks to prevent a terminal freeze, aligns perfectly with current research on cognitive load and task paralysis in ADHD. Recent studies analyze how divergent systems require task decomposition and external scaffolding to bypass the activation threshold required for execution. Public research reference: Not Just Me and My To-Do List, Understanding Challenges of Task Management for Adults with ADHD and the Need for AI-Augmented Social Scaffolds, 2026. RZiv 2600 3.17258.
Welcome to the black box, or what they call a maze, but it's only a mystery through a straight line haze. Step under the hood, see the wire and the thread, mapping out the latent space inside your ADHD head. It's a glowing star web, not a cabinet file. Every thought is a coordinate, connected for a mile. From the red of the apple to the fire in the street, the constellations firing, making everything